In this video, we're going to talk about the core stringer functions. Now, we're going to talk about a lot of functions. So hold on tight. We're going to go through them quickly. If you need to review things, just stop me and rewind me. Otherwise, let's get going. So the stringer core functions, as I said, always start with str underscore, or almost always do. Now, you should know something else about stringer functions as well. They almost always have the first two formal arguments. The first formal argument is a string, and that's the string that's going to be processed, okay? It's very frequently it's always a character vector. It's very frequently a character vector with many different elements, each of those elements just holding a different bit of textual data. So for example, again, if it's a book, maybe it's every sentence, or maybe it's every chapter, or something like that. If it's Twitter data, maybe it's different tweets, things like that, okay? That's the first formal argument of almost every stringer function. The second is a pattern. That pattern can be a regular expression at the beginning, and in this video in particular, the pattern will always be something very simple and concrete, okay? So it will technically be a regular expression. We're going to generalize that next time to see the regular expressions kind of in their fullness, but for this particular video, it's just going to be something very simple. So a string and a pattern, that's what you're getting. Now, stringer functions, and this is where it gets a little complicated, or functons, apparently, as I typed, can be roughly divided into 6 different categories. And each category is going to have 3 to 5 functions, something like that, okay? What are they? Detecting, so is the match there? Subsetting, give me the matches, or identify which elements have the matches. Resizing, so this is going to be kind of like a mutating thing. It's going to change it somewhat, okay? So to make it bigger, make it smaller. The input strings, that is, okay? Mutating is a proper change. So resizing is kind of just bigger or smaller. That's about it. Mutating is actually going to change the contents of the string. Joining and splitting, I think that's pretty self-explanatory. And then sorting or ordering, think alphabetical order, okay? Okay, now, we're going to take each of these in turn, and we're going to do it quick. So let's hit it. Detecting, you can see all of the functions that I'm going to talk about on this slide up top. Now, as a general paradigm, I'm going to use this text vector right here. So it's going to be called text. It's a character vector of length 3, and the elements are the color green. So 3 strings, THE, COLOR, GREEN. Very simple, but you'll see that that's actually a very flexible example to work with for a lot of things. Okay, so the first thing that we'll meet is strview. Strview is actually a little challenging to show in a slide deck, so I'll kind of show you how it looks in the console. So if you take the text strview E, so it'll say show me every match of the regular expression E. Of course, this is the regular expression itself. It's just the character vector, so it's kind of like a dummy little regular expression, but hopefully it shows the point. Again, the input string is here. The regular expression or the pattern to match is here, right? Every stringer function basically is going to have those, okay? And you can see them put in this kind of left angle, right angle, okay? So this has 1 match, this one has 2 matches, COLR has no matches, and that's it. You can also get an HTML widget out of this if you provide another argument to strview, but I'm not going to show that here. So you can just go and check that out for yourself to see how it works. strwhich is going to give you the indices that have matches, the indices of the vector text. So in this case, the first and third matches have a match. So you have the index vector 1, 3. strcount, how many matches does each input element have? So that's 1, 0, and 2 for obvious reasons. strlocate is going to show you the indices of the matches inside each input string, okay? Now, this is the first paradigm of something we're going to see commonly, which is that you're going to get the first match in each case, okay? So for example, in THE, the first match is, of course, the E, and that happens at location 3 in the element itself. So THE, that's the third element, and it ends there as well because it's, of course, just of length 1. And of the second one, there's no match, and of the third one, there's 1 match, and it happens in exactly the same spot, that E right there, okay? So when you do strlocate, it only matches the first match, okay? So you always get a matrix back. That matrix has 2 columns, start and end, and the number of rows is the number of elements in the original vector, right? So the color green, 3, so you have 3 rows, okay? In many cases, you want to see not just the first match, you want to see every match. To do that, you'll add a underscore all on the end, and you'll see that there's a lot of functions in Stringer that are like that. Okay, it'll be str something and then str something all. Okay, where you get all of the matches. Okay, you get this back as a list because there could potentially, for each of these elements, be many of them. So, for example, green showcases this, right? One of the matches is 3-3 and one is 4-4. That's the first and the second E. Okay, so strView, strWhich, strCount, and strLocate. Okay, subsetting. strsub is going to give you the characters between the start and the end. Okay, so if you say strsub2, it says start at character 2 and give me everything else for the rest of all of the other characters in the input element. Okay, 2 to 4 gives me elements between 2 and 4. -2 says start at the end, so it kind of cycles backwards. So -2 says give me the penultimate character and the ultimate one, okay, the second to last and the last of each of the input things. And so that's what you're getting there. You can also use this as a replacement function. This is a little strange to see, but it works just fine. So this says take every element of text and replace elements between 2 and 4, so that's 2, 3, and 4, with the single character, which is the underscore. So that's why you see T underscore C underscore R, G underscore N. Okay, so that's str sub. Okay, now I'm going to reset this vector because I had to actually replace it to do that. Okay, str subset is going to give you the subvector that contains the matches. So you'll probably forget this a lot at the beginning. Just review it and it'll come naturally. So str sub, that's the characters between point and point. Str subset says give me the kind of subvector that has matches. So if I say subset by E, it'll give me all the matches with E's in them. Okay, str extract will give you those individual matches themselves. So str extract E, the first has an E in it, and so it extracts that E. The second one has nothing, it does not have an E, so there's no match, and the third has an E in it. There it is. Okay. There's also an extract all, which would give you every match in each of the input elements. This is something that's not very interesting right now, but it will be when we learn regular expressions. So just remember str extract and str extract all. Resize, so str length, pad, trunk, and trim. Okay. Length is going to give you the number of characters in each of the input strings. So THE has 3, COLOR has 5, GREN has 5, 3, 5, 5. Okay. str pad is going to add text around the input elements until you have a certain number of characters. Okay. So str pad 6 is going to make each of the input things of length 6. THE doesn't have length 6, it has length 3. So it's going to add 3 spaces on the front. That's this one, and this one to give you 3. Okay, same thing here, space color and space green. Okay, now you can do this in many ways. So I could add the spaces to the right, or I could add the spaces kind of roughly to both sides to kind of center it, or I could put different padding things. In my experience, str pad is mostly useful when you're trying to do something graphical and you're using a fixed width font, and you want the length of those strings to actually print kind of like the same size. Okay, it's useful graphically and it's useful for output that's in the console. Okay, so remember str pad for that. Str trim is going to do the exact opposite. If there's white space on the sides, it's going to cut it off. Okay, so here's some text. Str trim is just going to lop off the so-called white space, however much white space there is, whether that's spaces, tabs, or new lines. Okay. str trunk is going to shorten something that is actually longer. So it's kind of like str trim, but it doesn't just trim off white space. It actually goes into the vector as well to kind of shorten it. Okay, example helps. So text str trunk to length 4. Well, color is longer than length 4. So it says C ... It's longer than that. Okay, THE is of course fine and green is not. Okay, now you can change the ellipses, and in fact, RStudio does this a lot. There's a single Unicode character which is ... all really close in one single character. Okay, and you'll see that a lot going around in tidyverse stuff. Okay, so str length, pad, trim, trunk. Okay, mutating. str replace, remove, and str to something else. Okay, hopefully these are actually pretty clear. I mean, the names are quite straightforward. str replace is going to swap matches that it finds. Okay, so in this case, text str replace all the E's, or sorry, not all the E's, the first E with an underscore. Okay, so text str replace E with an underscore, and you see the E here and the first E of green. If you want all of them, it's str replace all, and then that gives you the underscore in both of those E's there. Okay, str remove is actually just str replace. And in fact, originally remove wasn't actually part of it. So what people would do, it wasn't part of stringer. What people would do is they would take str replace and they would just replace things with the empty vector. So instead of underscore, just replace it with nothing. And that would be effectively removing it. Okay. Now that's actually a verb that is there. So I can str remove e or str remove all the e's. And now it's just gurn. Okay. So hopefully you'll remember it because of the gurn. It sounds really weird. So str replace all, and str remove. str2 whatever changes the cases. Okay, so str to lower makes everything lowercase. Of course, it already started that way. Str to upper, everything uppercase. Str to title, everything in title case. Str to sentence makes things in sentence case. Okay, so hopefully that's pretty straightforward. Joining and splitting. str to c, str dupe, and str split. Str to c is equal to paste 0. Those are like the exact same functions, okay? So you can use them totally interchangeably. It's going to concatenate two strings together, nothing in between, okay? So str to c, nums letters, does that kind of element-wise just like paste 0 would, okay? I can change the separating character, I can collapse, I can do kind of all of that stuff with str underscore c, just like paste 0, okay? And maybe I'll scroll this over quickly so you can see that they can both be used together just like with paste 0, okay? str dupe is going to take in a string and repeat it a certain number of times, okay? So nums str dupe 5 just says go to nums 1, 2, 3, repeat each of those elements 5 times and strc them together, right? Concatenate them back together. str split is going to take one, usually a relatively long string, and it's going to break it into a lot of little strings, okay? Usually this is by like spaces or something like that. So imagine somebody gives you a big string and it has a sentence or chapter or something like that, and you want to break it apart into words, okay? So what you would do is you would str split by white space, and it would break it up by the white space, okay? In this case, you see A, B, C, and I'm splitting. I can split by more than one character, right? I can split by a whole string. So I'm splitting by those, okay? So there's 1, there's 2. Notice that I get a list back here, okay? And that's because usually the input string that's passed into str functions is a vector, okay? If it's a vector, when each of those elements are broken apart, you're going to get a kind of a character vector for each input element, right? So the way that you need to store that is as a list, okay? So very frequently when you do this, you're actually going to, so this is what this would look like. Here's the input vector, str split, and so on. You would take the first element if you just have one of them, okay? You can simplify this into an array if it's nice. I'll say it's rare that I find myself doing this. I almost always just like break it up into pieces, and then I'll kind of parse that list afterwards to take out the things that I want, okay? So strc is paste, str dupe is, well, you'll see what the name of it is in base R in just a minute, and then str split splits strings apart, okay? Lastly, sorting and ordering. These do exactly what you think they do, but they do it for non-numeric things, okay? They do it so-called lexicographically, or alphabetical order, okay? So let's remember how these work on numbers. So here's a numeric vector, 1, -1, 0. When I sort it, of course, it sorts in ascending order, right? Smallest to biggest, okay? Order is going to be the list of indices, which when subset by, orders it, okay? That is to say, sorts it, okay? So X order is the same as the sort command, and rank is going to give you the ranks of those elements, okay? Those functions, those are base functions. They also work for characters, okay? However, they each have str stringer idioms, okay, or analogs, I should say, for text. So here's the same thing, CAB. I can sort it. That sorts the elements. Again, alphabetically, smallest to largest. Ordinary alphabetical order. I could do it decreasing by saying decreasing is true. I could str order it like this, and if I subset by that, I would have the thing sorted, and I could str rank, and it would give me the ranks of those elements. Okay. Last, I want to tell you about the base equivalence. We made this point at the beginning to say, hey, str is going to give you a lot of functionality that's already in base R. However, the names in base R are maybe not weird, but they're coming from kind of a Linux command line or kind of various places, okay? So what are those names? Here is a listing of all of the base functions, or at least the ones that I kind of could remember or am aware of, and their analogs here in Stringer. So str detect is grepl, okay? Str which is grep, strlocate regexpr, strlocate alt gregexpr. Okay, so these things are generally coming from Linux command line stuff, but it's just easier to remember strdetect, right, or strlocate or strextract than regexpr plus substr. Okay. By the way, I mentioned before strdupe. Here it is right here, strrep, which makes sense, right? A lot of these base function names actually do make sense. strsplit for str_split. Hey, that's not that complicated, okay? And when you're developing your own packages, you're probably not going to want to use tidyverse in those packages, so you'll use the base equivalents. So come back here when you need to see base equivalents for stringer functions that you're usually using.